Welcome to the DIY Honda Garage channel. The DTC P0095-16 refers to the intake air temperature, IAT, sensor 2 circuit low voltage issue in the Honda CR-V 2023 and newer models. This diagnostic trouble code indicates that the output voltage from the IAT sensor 2 is lower than the required threshold, leading the powertrain control module, PCM, to recognize a fault and store the DTC. The IAT sensor is crucial for monitoring the temperature of the air entering the engine. Its location is typically within the intake manifold or close to the air intake system, providing real-time data to the PCM for optimal performance and fuel efficiency. When this DTC is triggered, it can affect the air-fuel mixture, potentially leading to poor engine performance and increased emissions. Proper diagnosis and repair are essential for maintaining vehicle reliability and preventing long-term damage to the engine. The IAT sensor 2 plays a pivotal role in gauging the temperature of the air entering the engine. This information is vital as it enables the PCM to adjust the air-fuel mixture accordingly, thereby optimizing engine performance and efficiency. Typically installed within the intake manifold, the sensor provides readings that can affect several engine parameters. It has connections to the PCM, which interprets these readings to make necessary adjustments for fuel delivery and ignition timing. In the case of a circuit low voltage error, the PCM considers the voltage output from the sensor to be below acceptable levels, indicating a potential issue with the sensor itself or the wiring associated with it. For accurate diagnostics, it's crucial to identify this component's location and its relationship with the PCM, as any fault here can lead to degraded performance and emission issues. Several potential causes can trigger the DTC P0095-16, including a faulty IAT sensor 2, which is the main component being monitored in this scenario. If this sensor malfunctions, it will fail to provide accurate temperature readings, leading to low voltage output. Another possible cause is a shorted wire within the circuit, particularly in the wiring that connects the sensor to the PCM. Damage to the wiring harness can lead to erroneous readings and circuit failures. Lastly, a malfunctioning PCM itself may also be the root of the issue, especially if no other problems are found during the inspection. In a test scenario, isolating the sensor and inspecting the connected wiring is essential to determine the exact cause before taking further action. Drivers experiencing a DTC P0095-16 may observe several symptoms pointing to engine performance issues. One common symptom is poor performance, which can manifest as reduced acceleration, lack of power, or engine stalling. Additionally, if the IAT sensor is not functioning properly, the mixture of air and fuel may be incorrect, leading to an increase in harmful emissions. The vehicle may also exhibit a check engine light alert on the dashboard, which is an indication that the PCM has detected a malfunction. In some cases, there may be rough idling or abnormal engine sounds that accompany the warning light. Overall, being alert to these symptoms can help drivers take proactive steps to address the underlying problem before it results in significant engine damage or failure. The initial step in troubleshooting DTC P0095-16 involves turning the vehicle to the on mode. This provides power to the vehicle's electrical systems without starting the engine. Using the Honda Diagnostic System, HDS, one should check the intake air sensor voltage. The voltage should read higher than 0.08 volts under normal conditions. If the reading is below this threshold, it signifies that there is a failure, and further diagnostic procedures will be necessary to locate the issue. This step is critical because it helps isolate whether the problem lies with the sensor output or is related to other components in the circuit. Understanding how to interpret these voltage readings can greatly aid in an efficient diagnosis. In the second troubleshooting step for DTC P0095-16, the technician begins by disconnecting the IAT sensor 2, which is crucial for isolating the sensor from the electrical system. Following this, the PCM connector B must also be disconnected to further investigate any wiring issues. This step is designed to evaluate the interconnectivity and verify any shorts in the wiring harness that could be leading to low voltage readings from the sensor. During this stage, it's beneficial to refer to the provided open shorted wire inspection description for detailed methodology. It is important to recognize that issues such as frayed wires or incorrect connections can significantly affect sensor performance, potentially leading to erroneous readings and subsequent DTC generation. The third troubleshooting step is focused on checking the IAT2 INTA circuit for any issues. Once the necessary connectors are disconnected, the technician should measure the resistance in the circuit. Normal conditions dictate that the resistance reading should be greater than 1 megaohm. If the resistance is lower than this threshold, it indicates that there is a fault, which may include shorts to ground or other circuit-related issues. Any abnormalities found during this inspection will further guide the technician in identifying the root cause of the DTC. This step emphasizes the importance of ensuring that the wiring integrity is intact to guarantee accurate sensor function, which is critical in preventing further damage to the engine and maintaining optimal performance. The final troubleshooting step is crucial for verifying the functionality of the Powertrain Control Module, PCM. If previous inspection items have indicated normal conditions, the technician should now focus on the PCM itself. This involves checking its operational status to determine if it is functioning correctly. If all wiring and signaling from the IAT sensor 2 are deemed normal, yet the DTC persists, there is a significant possibility that the PCM is faulty. This final diagnosis is essential to implement corrective measures to rectify the issue, as a malfunctioning PCM can lead to several ongoing performance issues within the vehicle. Once a PCM fault is confirmed, appropriate actions for replacement or recalibration should be taken to restore normal operation. After completing the necessary repairs and replacements, it is essential to verify the effectiveness of the repairs made concerning the DTC P0095-16. The first step in this verification process is to clear the diagnostic trouble code from the PCM, which resets the system to check for reoccurrence. Following this, a test drive of the vehicle is crucial, as it allows the technician to put the vehicle through a variety of driving conditions, ensuring that the repairs have resolved the issue. During the test drive, it is essential to monitor the vehicle's performance against expected standards. Finally, confirming that no similar codes reappear is vital to validating the repair. Successfully completing this final verification step ensures that the vehicle is back to operating optimally, providing confidence to the owner about the work performed. Preventive maintenance is vital in minimizing the risk of future occurrences of DTC P0095-16. One actionable step is to regularly check the wiring harness associated with the IAT sensor for any signs of wear and tear over time. Inspecting connector integrity is also essential. Loose or corroded connectors can lead to misleading signals and low voltage outputs, triggering diagnostic trouble codes. Additionally, conducting periodic diagnostic tests using the Honda Diagnostic System, HDS, can help identify potential issues before they manifest into serious problems. This proactive approach allows the vehicle owner to maintain the efficiency of their Honda CR-V while potentially saving on costly repairs in the future. Awareness regarding these steps can significantly enhance the longevity and reliability of the vehicle. In conclusion, the DTC P0095-16 highlights a significant issue regarding the intake air temperature sensor 2 circuit in the Honda CR-V, which is critical for effective engine performance. A low voltage reading from this sensor often points towards underlying problems, such as a faulty sensor, shorted wiring, or even issues with the PCM itself. Conducting a thorough inspection using the provided diagnostic steps is crucial in pinpointing the exact cause of the trouble code. It's important to remember that early detection and resolution of these codes can prevent further complications and enhance the driving experience. Moreover, implementing preventive maintenance measures significantly contributes to the vehicle's overall reliability and performance, ensuring that the Honda CR-V runs as intended for years to come. Please like and subscribe to the channel. See you next time.